Hello and welcome to a new video. Here we'll be solving CSIR UGC NET 2019 June physics 2 problem out of 55 problem for the question paper. So all the previous videos are there in the playlist which you can check in the description. So let's go on with the first question. So the question goes something like this. In the following circuit, each device D may be insulator with a probability P or a conductor with probability 1 by P. So this is the circuit. The probability that a non-zero current flows through the circuit is. Now this kind of questions are very tricky and very easy. So let me just draw the circuit. Okay, so this is our circuit. This is the first part and this is the second part. Okay, now this is one block and this is another block. Now if you look at this region, you will see that each individual component has a probability P. So if 3 are in parallel, the probability of being an insulator will be P cube. Why? Because just think, suppose 3 circuits are in parallel. So if one of them behave like an insulator and any one of them behave like a conductor, it will still work, right? So when they are in parallel, the probability that it will behave like an insulator is P cube, because all of them need to be an insulator in that case. So P cube is the probability that all of them are insulator for this circuit. So P of I is P cube. Then P of being a conductor will be 1 minus P cube. Right? Now let's check the other circuit. Let's check this circuit. Here P of being an insulator will be P. Probability of being a conductor is 1 minus P. So what is the probability that a non-zero current flows through the circuit? So the total probability will be P of circuit 1 times P of circuit 2, which is equal to 1 minus P cube times 1 minus P. So the correct answer is option D. Hope you understood this problem. If you still have some doubt, just go back in the video and watch this section once again. Okay, so let's jump to our next problem. Here we have a very typical maths problem. So we have given a differential equation with a boundary condition and these are the 4 options. So the equation is given as x dy by dx plus 1 plus x y equal to e minus x. Let's simplify. Let's divide by x. So then it will be dy by dx plus 1 plus x by x y equal to e to the power minus x by x. But this is same as dy by dx plus py equal to q, right? And this we are familiar. Now what we can do is, here we can compare. So p is equal to 1 plus x by x and q is e power minus x by x. Now let us find the integration factor. To find the integration factor, what we need to do is we need to integrate e power p dx. So let us substitute the values, that is 1 plus 1 by x dx, because 1 plus x by x is 1 plus 1 by x, and then this will be e power integration dx by x times e power integration dx, which is equal to e to power ln x e power x, and you can write as x e power x, because e power ln x is equal to x. I hope you remember this. Okay, so we have found out the integration factor. Now what to do? Now we know the very famous equation which we need to solve this kind of problem. Whenever we find the integration factor, now what we have to do is we have to plug in, that is we have to write y times integration factor equal to integration of q times I times dx plus c. So here if we substitute, it will be y x e power x equal to e power minus x by x x e power x dx plus c, or y e power x equal to x plus c. Now the boundary condition is given. At x equal to 1, y equal to 0. Now so if we apply the boundary condition, so at y equal to 0, at x equal to 1, this is the boundary condition. So let's substitute. If you substitute x equal to 1, then it will be y times 1 equal to 1 plus c, but y is 0, so 0 equal to 1 plus c, or c equal to minus 1. Then the equation will turn out to be y x e power x equal to x minus 1, or y equal to x minus 1 by x. If e to the power x come here, then it will be e to the power minus x. So this is the solution to this problem. So option A is the correct answer, right? So this is how you solve this kind of problems. Hope that you learned how to solve this kind of problem. And so whenever let me tell you a few important points, that is, let's say you are given a similar problem, but with slight modification, with more number of component in series or in parallel, then you just have to think that how the probability will depend on adding more component. Let's say if I have one more component here, then the probability would then be 1 minus p4. So all these things I hope that you understood and you'll be able to solve. Similarly in this case, generally in NET, GET, JEST, everywhere some form of differential equation will be given and boundary conditions will be given. Then you just need to arrange the equation. So in this part of solution, if you ask me what is the most important part, I would say that this is the most important part, because you have to arrange the differential equation and then figure it out how you will solve the problem. And then once you arrange, it's very easy. You may be needed to find the integration factor, or you can just solve it directly if it is easy enough, and then you will get your solution. So that's it. If you like the way I'm teaching, then do subscribe, hit the notification bell, do like, and if you have any thoughts, please do comment. Thanks for watching. This is Physics Plus.